We should probably put something underneath, like a weight.
Like a weight? I don't know. Hey, everyone.
Hey.
We're here. There's so many things right now that are just precariously hanging on just things.
I think our theme music should play anytime anybody pours a drink.
Oh, yeah, that would be great. You know, it's like, I gotta turn myself. Sorry, I mean, I gotta
You
use
want me to go like
Mike
this?
I gotta use Mike as my, these chairs don't, like,
And
tape.
to think I thought it was because you loved me that you wanted to touch my arm.
I do. Anyway.
All right.
Welcome back. It's been forever, everybody. We've been out. We've been doing things for a month. When was our last episode? Like a month ago?
It was a month ago. It was 4 weeks ago.
Yeah. And
what was that episode? I don't even remember. What was our episode 4 weeks ago?
Brandon was on with Kat. I don't know. I'm sure. I can't remember either. But we got a fun one for you. I know
Comments.
Comments. That's right. That's right. Because the green comet. I know we said
which we never saw.
We were going to talk about astrology on this episode, but we're not going to be talking about astrology. We're going to save that one for when we have.
When you can put some effort into it.
When I have time to put some effort into it, since we're still in a transitionary phase right now.
Yeah, and I need to prepare the drinks with the moon water.
Yes, you have to set it out in the moon.
In the full moon?
Overnight or some crap. I don't know.
So basically what I need to do is I need to put like vodka and
in the moon.
And whiskey just outside.
Yeah, so it can be then it's really moonshine.
Oh, yes.
Actual moonshine. Yeah, we need the full moon. We need that full moon. Excuse me while I adjust my nose piercing. Okay. All right. Are we ready to get this party started? We got some fancy glasses today, everybody.
Well,
I do.
Well, I mean, I do as well,
yes,
but it's for one drink for me.
I don't know how people not spill it. Okay. Anyway.
I did pour a lot, but and you still have a lot.
Yeah. Oh, I got plenty.
All right, you ready?
Yeah, I'm ready. Get the show on the road.
Hi, everyone, and welcome to Cosmos with Cosmos. As always, I'm Mike.
And I'm Liz.
And that's all we got.
Yay! Brandon's out on assignment?
Yeah, he is on the road, hoping to get through immigration.
Heading to South America.
Going to Colombia, down in South America. And, so they're already putting money on you spilling.
Oh, gosh. I mean, that's an easy win.
Yes. Katie, I'm with you on that.
Speaking of which, then.
Yeah, let's go right into what are you drinking?
Oh, but we have to say our topic first.
Oh, we're
out of practice, everyone.
Today we're going to talk Magnetars.
Magnetars.
Which really sounds like it's a unicorn or something.
It doesn't sound. It sounds like a mythical creature.
Yeah, like we'd find it in Hogwarts Legacy.
Magnetar.
So, so we're going to talk about Magnetars, what they are, and what we know, what we don't know, and that type of thing. And before we get into that, though, what are you drinking?
I am drinking the heart-shaped box.
She will explain that reference later.
Am I explaining it later or now?
Oh, you can do it now.
Now. Oh, yes, because, a good old classic Nirvana song has a lyric in it that says, fall into my Magnetar pit trap or whatever. And I remember listening to it recently, and I was like, oh shit, they say Magnetar in it. I was like, so I gotta bring that in. So cheers to Kurt Cobain and Magnetars as well. My love of grunge and science and astronomy coming together.
Cobain.
Cheers to Kurt Cobain. Courtney didn't do it, everyone.
No, she didn't. No, she
didn't. And what's in it? It is vodka, peach iced tea, some lemon juice, some honey, and a little sugar on the rim. Basically, it's a tea-teeny, if you will.
Yeah.
Tea-teeny, if you will.
With podcast mom Karen, we actually talked about if putting gin in it would affect it in any kind of way. I mean, I also want to try it with limoncello. Instead of lemon juice.
I'm not a gin fan, so
no. But that would be for Karen.
Yes. What do you got
going on
other than a heart-shaped box as well?
I have a second one called a heart-shaped box, but this is very similar to Liz's drink. It's called the Bose-Einstein condensate. Condensate.
Bose-Einstein condensate.
We did pregame with one of those drinks.
It's the BEC.
The BEC. Yeah, that's exactly how they put it. And like, they'll say Bose-Einstein condensate, and then in the scientific papers they shorten it to BEC.
Yeah, of course they do.
Yeah, and so this just has the same peach tea and vodka, but I'm leaving the honey and stuff out.
So we're in a peach tea kick. Well, you know what? Cheers to Einstein then. You know, and to our dearly departed musicians and scientists.
All right. Oh.
Jack has a Nutella cold brew frappuccino. I know you're not a fan of Nutella. I like Nutella. I love hazelnut. Jack,
I will do
with
it
you right there.
I will do it, but I'm not necessarily the biggest fan of it.
Right.
But I'll do it if there's nothing else. All right, so those are our drinks. As always, follow us on all the things on social media, Twitter, Drinking Cosmos. Everything else is Cosmos. Follow us. Rate what?
Oh no, I'm just mouthing words to the camera.
Oh.
Follow us.
Oh, okay. Rate us, all that kind of good fun stuff, and don't forget to tell your friends about it and how they can join us.
We could be like real social media people or YouTubers or whatever it is, and be like and subscribe.
Yeah, wherever it is.
We don't have one. We don't have
one.
Well,
we can cut it. All right, so let's point down. Let's point this way.
Now I'm gonna have to remember to put this in the edit.
And then point this way.
Oh, okay.
And then
all
up. Right. Whatever. Just
all right.
Point to it. Like over there.
All right. My mom, podcast mom, she has an Earl Grey lavender hot in honor of the last season of Picard.
Oh, yes.
Yep.
Yeah, definitely check that out. Great. Also, hang out with us, literally, for the hangover. So don't forget to join us for the hangover immediately after this. If you are not watching this live,
find it on YouTube.
Find it on YouTube. Yes, indeed. All right. And also, if you are interested in getting some really amazing art, go to Etsy and look up Wildixia and get their art, get Katie's art. Also,
good timing, Ron, for joining the show.
Yeah,
so we're about to
exactly.
Promote your ass.
All right, so MrProctorShow.com. Check Ron out. Also, he has a new thing on YouTube that is coming up later next month, mid-March, March 15th, I believe is what he told me. It is BlenderUniverse.tv, and so what Ron's going to be doing is him and a partner are going to show you how to use the animation package, modeling package of Blender.
Is Blender still free?
Last I heard, it was free. And so it's
Make
open
those
source.
Monkey heads.
It's open source, so you can use it for all your animation needs. And Ron is going to show you how to use it.
He is the blend master.
He is, really. And the guy that he's doing it with, I can't remember his name. He's been doing it since 2010, so both of them just have a shit ton of knowledge for it.
Good for you, Ron.
All right. Also, speaking of a lot of knowledge about the universe, go check out Jack's place, rollingbluffsplanetarium.com in Council Bluffs, Iowa. So if you're kind of in the southwest corner, I think the southwest corner of Iowa, if you're in the whole state of Iowa, it seems like a small state. We live in big states, so make a trip to Jack's place and let him take you on a tour of the universe. Yes, indeed. So, all right. And also, every other Wednesday, the shot.
The shot.
Yes, little, what do you call it? Bite size?
Just, bite-sized bits of astronomy or shot-sized bits of astronomy.
Yes, real small drink size.
Shots of astronomy.
Yeah, and so we talk about, we tell stories, and it's Brandon's favorite part of Cosmos and Cosmos.
Yeah, it's
and
fun.
So
we just had an episode come out last Wednesday.
We need to make some more, don't we?
But we're going to need
to make some more, because I think they go to March.
They go to March, yeah.
And as always, if a puppy barks, it'll be interesting to see if we have a puppy bark, but if dog barks, take a drink. If there's a Star Wars reference, take a drink. If there's a Lord of the Rings reference, take a drink, and there's talk of a new Lord of the Rings movie from Warner Brothers. It with New Line Cinema. So they're actually sticking with New Line Cinema, and Peter Jackson says, talk to me.
Ooh,
So,
you better talk to him, Warner, because, yeah. Anyway, don't fuck it up.
Don't fuck it
Warner
up.
Brothers.
Yeah, I know, right? Don't. This is something that you cannot fuck up.
Mm-hmm.
You have to. There will be a revolt if. All right, so.
But what's funny though is that in Lord of the Rings, Ian McKellen, of course, plays the legendary Gandalf, but he is also Magneto in X-Men, which uses magnetism, and we're talking about Magnetars.
That is a really good segue. That is a really good segue. Thank you.
You're welcome.
I had a different statement that I
wanted to throw in. I was just planning to get like an Ian McKellen Magneto reference thrown in there somehow, and that's how I did it.
Yeah, no, that was really good because when you started talking about Ian McKellen, I was going to make a different statement about Harry Potter. And Ian McKellen. He was asked why.
He was asked to be Dumbledore?
He was asked if he wanted to be Dumbledore, and his response was, I played Gandalf. Why would I want to be Dumbledore? Which I thought was fucking
that's a gangsta
brilliant.
Right there. Yes.
That was very brilliant. All right, so let's talk about these things called Magnetars.
Yeah, Magnetars. Are they like magnetic centaurs in space?
It's exactly what they are. So that's our episode, guys. Thanks for joining us.
Solved it.
See you in 2
Cheers.
weeks. We don't even know what we're going to do in 2 weeks, do we?
Nope.
All right.
Actually, High in the Sky.
High in the Sky. All right, so let's talk about kind of just real quick what is a magnetar. So maybe you've heard of them, and so
yeah, listen to Heart Shaped Box by Nirvana, and you'll hear of them.
That's really all you need to know is Kurt Cobain. First of all, a fucking grunger.
I wonder if he knew what a magnetar was, or if he just heard the word magnetar and then like threw it into as a song lyric.
Maybe.
We'll never know.
No, he did kind of end that possibility, didn't he?
Yeah.
All right, so magnetars they're neutron stars.
Neutron stars.
Yes, but these are neutron stars that have really intense magnetic fields.
Should we start with what a neutron star is, or how you get to a
we're
neutron
gonna
star?
get there.
Oh, we're going to get to that bit
In
of stellar
fact,
evolution.
Yes, in fact, I do plan on kind of having you talk us through that. There aren't many notes.
Because he knows I love stellar evolution.
There's not a lot of notes.
Yeah.
So I figure, you got it. But these magnetars have magnetic fields that are, neutron stars already have really intense magnetic fields.
Anything that has like some sort of convection is going to have some sort of magnetic.
Yeah, but these
field.
only have convection.
Oh God. Oh, my brain's already.
So, all right. So the neutron stars have really strong magnetic fields to begin with, and so much so that they can focus light out the top and bottom of neutron stars, and they're spinning really quickly. And so, from our perspective, as those beams of light pass through our view, they look like they're pulsing.
So pulsars.
Pulsars.
And pulsars are neutron stars.
Yes, all pulsars are neutron stars. Not all neutron stars are pulsars.
Ooh.
Yes, because the lights aren't flashing. We're not lined up with their poles.
Okay. So we have to be lined up for it to be a pulsar.
Yeah, and maybe for a shot, I will talk about the little green men and pulsars. But anyway,
I got it now because I'm intrigued.
So with magnetars, though, magnetars have a magnetic field which is usually 1,000 times more powerful than a neutron star.
Okay.
So these are really powerfully most magnetic things that you can have in the universe.
Can that be related in a way that's more something we're familiar with?
Yes.
Because
I can do that. Have you looked at this?
I did look at it.
Okay, cool.
I briefly looked at it.
All right, so it is actually about 1,000 times more powerful than a regular neutron star, which for us here on Earth is 1,000 trillion, also known as a quadrillion.
Quadrillion?
Times more powerful than the Earth's magnetic field.
Quadrillion?
But if you wanted to reproduce the magnetic field of a magnetar. You just need to go down to the store and get 100,000 trillion refrigerator magnets, which is a lot.
100,000 trillion.
Yeah, so basically it's 100 quadrillion. Refrigerator magnets. Which we were told this really bizarre thing that refrigerators you can't put magnets on refrigerators anymore, which I don't know, but
Newer
anyway.
refrigerators are magnetic, and that just is like, what's the point then? Where are all your magnets going?
Okay, so here's the thing. All right, so that's a lot of refrigerator magnets. Did you spill it?
No, I dropped a piece of sugar. It's a piece of sugar. I didn't spill any liquid.
I was about ready to say, Katie gets $5.
Here's a piece of sugar.
Anyway, so all right. If these magnetic fields are so strong that if a magnetar were halfway between Earth and the Moon, so what is that, about 125,000 miles?
Yeah, roughly, sure.
It would wipe every credit card on the Earth. It wouldn't wipe your balance, but it would just make it so that your credit cards don't work.
Wow, would that wipe hard drives? And
it would wipe hard drives.
Anything
it would
that
wipe
uses
hard
magnetic
drives.
Wow, that would totally mess us up.
Yeah, okay, so, but what is really, and I found this out in the research for this, and I thought this was absolutely amazing. So, in a very macabre kind of way, if a magnetar were only 600 miles away from you, it would rip every electron off your body. It would just completely just rip it off of every single atom in your body, and your body would be nothing but monatomic ions, which are just single atoms without any electrons at all.
God, I want to know what that would look like if all of a sudden.
First of all, you die instantly.
You just poof, and then.
No, but okay, so magnetic.
Is that like Thanos' snap? You just.
Pretty much for everybody on Earth, yeah, 600 miles.
Wow.
That's not far at all. No. And so for everybody who's a little worried now about magnetars, because I do know that we do tend to say that like the universe is trying to actively kill you.
If you were worried about magnetars, you don't have to because you still exist.
Yes. The closest one's about 7,000 light years away.
7,000 light? Okay, so that's a safe.
But we are going to get into something here.
Yes.
Okay, so
this is just another series in the many ways space can kill you and is trying to kill you.
Yeah, the universe is actively trying to kill you, and in an article I read, it literally said the Earth does it in 80 years. Just on average, the Earth does it in 80 years. So, the universe really is trying to kill you, and this is just another way in which it can.
Yeah.
I mean, everything, really and truly, what separates us between, our fun life here on Earth making podcasts, talking about astronomy, and
utter death
is this very thin atmosphere.
Yeah.
And Earth's magnetic field.
Yes, which that stops it going then. Bye.
Yeah, and so these things are basically out there. These monsters are basically out there, and fascinating.
Monster magnets. Monster magnetars.
Monster magnetars.
That should have been my drink. Oh, that was a good drink name.
That was a good drink name.
Magnetars. That's a band, Monster Magnet, for those of you wondering.
All right, so let's talk about how we discovered these things.
Yes, because a neutron star is going to be, it's small, but emitting a lot of energy, but still these things are far away. We need to have powerful enough equipment to be able to register any kind of signature from them.
Right, and so our first thoughts of magnetars came in 1987.
Who thinks of these? Who goes, oh my God, there's really magnetic stars.
These are...
We'll call them magnetars.
These are scientists who probably have had, some drinks.
All right.
Maybe some weed. Open up the mind a little bit. But anyway, so these were first proposed in 1987.
All right.
These were proposed without any evidence that they existed. So they were proposed in 1987 to try to explain some of the things that we were seeing.
Okay.
Unbeknownst to them, though, I don't actually have in my notes who was first to propose it. I should have added that, but and I don't remember the name.
Dude somewhere.
Yeah.
Some white dude somewhere, probably.
They were first detected in 1979.
Oh, so
this
before
was
they
prior.
were before they were proposed.
Yeah, but it was just chalked up as this kind of bizarre event, and they didn't say it was a magnetar until many years later. Okay. So in 1979, 2 Russian probes were measuring basically gamma ray counts, and the typical is about 100 counts per second, and it went from 100 counts per second up to 200,000 counts per second in less than a millisecond.
Oh.
And then it died back down. And so astronomers were obviously very intrigued by this.
Yeah.
And so
aliens?
Some astronomers, they basically were able to triangulate where it came from. And it originated from a known supernova location in the Large Magellanic Cloud.
Oh, that can be seen in the southern hemisphere.
Where Brandon's going.
The Large and Small Magellanic Clouds, named after Magellan, the explorer, I am assuming.
Yep. And so, first European to see him, and since he's European, he gets to name it, right? Meanwhile, everybody
all native peoples and Polynesians, etc., down south have been looking at them since time immemorial.
I know, right? And so they were able to figure out that this actually came from an actual known supernova location. But they didn't call it a magnetar at that point.
Okay, they didn't have that fancy verbiage.
No.
Do they know of pulsars and neutron stars?
Oh, yeah.
Yes,
they do know of that.
So these are established.
Pulsars originated in the 60s.
Right, okay.
And we're getting this pulse. Jocelyn Bell, I believe. Oh, maybe I did do a shot about this.
I think you did do a shot about Jocelyn Bell, yes.
And it was a repeating thing and seen as a little green man.
It's a star and it's pulsing. Pulsar.
Yep. And so it basically took astronomers until 2008 to actually realize that this was originated from magnetar.
Wow, 2008. That's a big jump in time.
It is.
When did they who did you put down who thought of the name Magnetar?
No. That was in 87 and I should have put that in my
that's
notes.
when they first were like Magnetar.
Yeah, and even in my head, in my head when I was writing this up, I was like, I need to find out who that is so that I can put it in notes, and it just didn't happen because I was like, I'm going to call my parents.
Podcast Mom, I think, was that a single event or happened a lot? I think that
it actually, interestingly enough, is not the only time this happened since 1979.
Okay.
It has repeated in, they're called soft gamma events or something like that.
Soft gamma events.
Yeah, and so obviously it is not to the extent that what happened in 79, but it actually has repeated.
Okay.
And so, yeah. So, it's a great question.
Good question. Thanks, Podcast Mom.
And so these events do repeat. I need to take a drink. Otherwise, that was just a waste of a movement to pick up my glass. I'm all about efficiency. All right, so so how many magnetars are out there that can just shoot us with gamma rays and stuff like that? There are 3,200 known neutron stars.
Neutron stars. But that seems,
low?
Yeah.
Well, they're hard to spot.
Right. Okay.
And so
fair
that's
enough.
why I say known.
Fair enough. Okay.
Yeah, known. There's billions.
Yes.
And billions in the universe. But there's only 3,200 known neutron stars. And of those, only 31 are magnetars.
Wow.
So 10%. 10% of neutron stars, for whatever reason, become magnetars.
That's interesting. We know, it's so... you said 10% become magnetars. Mm-hmm. Brandon's favorite fact being that there's a supernova and we'll get into stellar evolution. There's a supernova that's happening every second in the universe. So then.
Yeah, and I mean, if you
how many magnetars are gonna? We'll get there.
Yeah, I mean, if you say 3/4 of those, 75% are neutron stars. That means every second, there is a 7.5% chance that there is a magnetar that is created. Robert Duncan and Christopher Thompson.
Katie Googled who came up with the name magnetar. Coined.
Okay, so
Astrophysical Journal.
So I bet you what happened was that they came up with the idea of what this is in '87 to try to explain some shit. They needed the
data and everything.
But then in '92 it became this is what we're going to call it.
Okay.
It is Magnetars is really quite a pop culture type name. You know. I mean, because in physics...
it sounds cool.
It does sound really cool, but I got to tell you, in astronomy, it would be something like super intense magnetic field neutron stars.
So they're like, a star that looks like it's pulsing, we'll call it a pulsar. A star that is super magnetic, we'll call it a magnetar.
But the thing is, astronomers now call them pulsars because of pop culture, but in the 1960s they weren't called pulsars.
Oh, okay.
And so, so Jocelyn Bell spots them, and then it becomes, what is this? And so what is this object? And so, it's a neutron star, and yeah. All right, so Podcast Mom, do they stay magnetars or switch back and forth? Well, the real definition of the magnetar, really what separates it from a regular neutron star, is its magnetic field.
It's just
and so the magnetic field is not flipping back and forth. That would be some really interesting physics going on that would cause that. But no. So once a magnetar is created, and this magnetar, at least as far as like in a very pop culture kind of way, theories go, that the magnetar is created at the moment of supernova. And so it basically stays a magnetar until it loses that magnetic field somehow. And I mean, the thing is, all right, we'll at least get to where does it come from.
Yeah.
But I can tell you that for right now, we would not understand a way in which it could actually lose its magnetic field.
Okay.
And so, all right.
Once a magnetar, always a magnetar.
Yeah. Until it's not. Yeah, magnetic chickens all the way down.
Magnetic chickens.
Ryan, like we will on occasion say it's chickens all the way down. And so, and we think of you every time we say that. So,
anytime we say anything all the way down, we have a little thought of you.
I really should do the turtles all the way down.
Turtles all the way down. For a shot.
For a shot.
Yeah.
I think I'll do that.
Yeah.
I think I'll do that. All right. So here's the question: Where do these things form? And so when I was putting this together, it really kind of split into two different areas for me. One was stellar evolution and just generally how neutron stars form. And then the, where do they get their intense magnetic fields? And so I think I'll let you talk about stellar evolution.
Stellar...
I will move my drink. We'll move yours.
Evolution. This is my game. Turtles are like armored chickens. They even like eggs. Turtles are armored chickens.
Oh my god! I'll never see a turtle the same.
Turtles are cuter than chickens.
I will never see them the same.
Oh my god! Anyway, what came first, stellar evolution or the egg? Anyway. Stellar evolution, I love it. It's basically the life cycles of all stars. They're born, and a big cloud of gas and dust, and depending on how much stuff is in that cloud of gas and dust and how long it takes them to form, they either collect a lot of material and become real big stars, or, they don't collect a lot of material and they become real little stars. Maybe there's a bunch of little stars that form all together, or one big star that formed, or a couple big stars that formed. But eventually, they basically, throughout their entire lives, have an internal battle going on. You have the outward force of energy battling the inward pull of the star's gravity, constantly fighting. But eventually, a star is going to run out of energy. Gravity is going to win in the end. And
what creates that energy?
It is the nuclear fusion. It's,
Yep.
Yeah, it's basically it's hot enough in the cores of stars that you can have nuclear fusion. We can't do it. We can do fission, but you can have a hydrogen atoms coming together to make helium, and that releases energy. And kind of as it goes through its processes, it goes through different elements of creation depending on how big the star is. But eventually, it's going to run out of energy. It's going to run out of basic material to convert. So stars like our sun, they kind of dwindle down and kind of puff off their outer layers, and the core shrinks down to become a white dwarf. But really big stars, they run the gamut. All right, they get up to iron. All right, they started to try to make iron in their cores, but iron doesn't release energy, it consumes energy.
Sneaky little bastard.
Sneaky. So once that happens, gravity's going to take over, and what gravity essentially is going to do is go poof, and that core of the star is going to collapse in on itself, with cause a shockwave that just blasts the outer layers of the star off of it, and what remains is typically a neutron star. Now, depending on the size of the initial star, it can have so much gravity that then that neutron star keeps collapsing until it's nothing more than a single mathematical point, aka a black hole. That's pretty much as far as it's gonna go. That's the last, very, very last stage that can possibly happen to a massive star, is to become a black hole. But then a magnetar, well, that's going to be a star that exploded. That was a neutron star, but then there's something that's gone on.
Yeah.
To have it have a ridiculous amount of
magnetic
energy.
Yeah, and what causes it? No fucking idea.
We don't know what causes it.
We don't know.
We don't know.
We don't know. Yeah.
We can go all the way to black holes, but magnetars were like, it's real magnetic, guys.
Yeah, and I mean,
make an etch-a-sketch out of it.
Yeah. I mean, it could be just as simple as the star that went supernova, for whatever reason, and 10% of these happen to have just an intense magnetic field.
They just start with that. They just already have. They just have been born with a intense magnetic. They're born that way.
They're born that way. Yeah.
They're born magnetic. Not everyone's born magnetic.
I guess. All right. So completely, I'm freely admitting this, is that I have not been in the middle of any kind of physics research in decades. And so it's 25 years. And so my thought is that, I don't know. I don't know about this. I would think that the physics of just such an intense magnetic field from the original star would cause some problems for that star. That said,
would it make it really unstable and
those magnetic fields are going to be ripping. Because on the surface is nothing but plasma. It's all these charged particles, right? And so it's going to be just ripping off charged particles off the surface of that star, and so I need to think about it a little bit more. That magnetic field is going to be even stronger in the core or near the core, and I just feel like it would disrupt stuff.
Could it possibly mean that these stars maybe even have a shorter life? Or, like they're basically self-destructing themselves.
Yeah, see, that's what I have to think about more, because I do think the solar wind is going to be insane off these stars. And that's going to be, over time, removing a lot of material. And it's going to... removing that material is going to have this weird effect where it's going to extend the life of the star, because it's losing material.
Yeah.
But I got to think about it more. This is some saying. All right. This is stupid for me to say. Okay. Saying that the original star just had an unusually strong magnetic field may be true, but it's very lazy. On the parts of physicists and astronomers.
There's something more maybe in the process of its evolution, and that maybe even the supernova itself that is
and to me this almost borderlines on intelligent design, where it is, we don't fucking understand it, so God did it.
We'll leave it up to the heavens.
We don't really quite understand the mechanism, so clearly the star
Magnets,
had it.
How do they work? You can't explain it.
That and tides. Can't explain it. But there is actually another idea as to where they come from. And that is that the interior is a superconducting fluid that is made up of neutrons, quarks, and the Bose-Einstein condensate.
Oh, so what is this Bose-Einstein condensate
we'll get there.
What you've drank?
And so as the star rotates, it acts like just a huge dynamo that just creates that intense magnetic field, which to me is the whole Occam razor thing, and that is the simplest explanation.
Well, and neutron stars are already rotating pretty fast, right? Especially pulsars, we can measure that.
And so it's really gonna drag that. It's really gonna spin that dynamo.
Get that magnet going.
Yeah, and so if you spin a dynamo, it creates this magnetic field, and
do we have data on the rotation rates of these stars?
Oh, we do. You did look at this shit.
I've skimmed through it. I didn't know. All
right,
it's just a question from my own brain. They spin it right round, baby, right round.
Oh God, I put it in there somewhere. I can't.
Okay, we'll get to it.
All right. Well, anyway, so the Bose-Einstein condensate was actually predicted by Einstein in 1924. So Einstein doesn't really believe in some of the interpretations of quantum physics.
Right.
But there was this pioneering paper. I believe he was an Indian physicist from India, Satendra Nath Bose, and his paper was just on quantum statistics.
Any relation to Bose speakers?
Oh yeah, no. I invented them.
Okay.
Yeah. All right. So he writes this pioneering paper, just on quantum statistics, and as Einstein does, Einstein takes it to the next level. It's what he does.
Yeah,
I mean,
he can't get out of his own head.
Seriously has taken things to the next level.
What thought experiment did he do?
Yeah, and without a doubt. And so he writes this paper in 1925, and basically says that there's this thing, and he gives Bose full credit. He gives him full credit.
Oh, so good for he's an
And it ones. Really and truly is why Bose's name is first. And so
also alphabetically.
Well, that's true. That is true. And so Einstein fully gives him credit. This is where it came from. I'm just kind of taking it to the next level. Cool. This type of thing. And so the Bose-Einstein condensate is basically this fifth state of matter. Solid, liquid, gas, plasma, Bose-Einstein condensate.
the Beck.
I mean, we all learned about it in elementary
Yes,
school.
I remember.
Okay, so basically, it's you can take a group of atoms and cool them down to almost just within like a hair's whisper of absolute zero.
Okay.
So it's very cold.
Very cold.
Very cold.
Very
and
cold.
These atoms, because there's not a lot of energy, free energy for them to absorb and kind of move around. There's just not a lot of motion between the atoms.
They're pretty static.
Relative to the atoms. Yeah.
Stationary. They're cold.
So they're very cold. They don't move relative to each other. That doesn't mean electrons aren't whizzing around the
Those pesky electrons. They're all over the place.
So they're definitely moving, but relative to each other, the atoms really aren't. And so basically, what they do is they clump together.
Well, they're cuddling for warmth.
They're cuddling. They're cuddling, and as they cuddle, they basically get the same energy state. Okay, easy enough. Whatever.
Okay.
So they all kind of had the same energy. And so as they cuddle, they kind of just transport energy amongst themselves, and they all become equilibrium, and they all have the same energy state relative to each other. And from a physics point of view, they basically become identical.
They become one.
They become one. Yes, indeed. So
yeah, they just snuggle down. It's a snuggle down party.
And so basically, even though this group of atoms is made up of billions of atoms, we'll say.
Oh.
They're
in my head, I'm like thinking of like 10.
Well, okay, but reproducing in a lab probably is 10. But even though you have all these separate atoms, they all have the same energy state, and so they all behave as if they are a single atom.
Oh, okay.
Yeah, and so this is a very rare state.
It's like I think of like those groups of birds in flight that they basically become one giant just blob of a creature that's flying.
And so it really is kind of like that.
Yeah.
It really is kind of like that. And so typically we can recreate them in our lab at very cold temperatures. However, you can also recreate this effect at just extreme heat and magnetic fields.
Oh.
And so that's why this is why you can get that Bose-Einstein condensate at the center of a neutron star.
Oh, okay, because it's super hot.
It's
super magnetic.
Yeah, and so I mean, what's really
all the way down, Ron.
What's really crazy is so we say, for example, that Uranus and Neptune are ice giants.
Yeah.
Okay, but at their cores, I mean, that ice can exist at extreme temperature as long as the pressure is there as well.
Okay.
So it's not just one thing; it's it's multiple things.
Yeah.
And so that's the way it is with this Bose-Einstein condensate, and that's why I feel like this is probably the most plausible. But I'm not a PhD physicist,
and no one has enough data to really, make it a theory of, it's just kind of like, well, this is what it could be.
Yeah, and the thing is, it took so Einstein writes his paper in 1924, 1925.
Yeah, we didn't even propose magnetars until the 80s.
Into the 80s.
Yeah.
But the very first time that we were able to create this, 1995.
Oh, wow.
And then cue up those Nobel Prizes in 2001. So, so the thing is like Einstein was so far ahead of his time in creating these theories, these thoughts. It took 100 years for gravitational waves.
Yeah.
It took 70 years.
Yeah, our technology always has to catch up with our ideas.
Yeah.
First. Ron says they made a lot of science first, and then they looked at it and said what they found out.
Yeah, I gotta tell you, 1920s, or the first half of the 20th century, amazing for science. Not so much for people of color.
Or
Amazing
women.
for science. Or women. No. But, oh my God, the stuff that came out of these physicists' heads in the
Well, they had more
1920s.
time to dream. They had more time to, think about, do thought experiments and think about random shit because, they didn't have to go
Yeah.
farm the fields or
And
hunt their food. Or...
Einstein does a lot of the first thoughts, just his thought experiments. He's just literally in his head thinking about shit. Like, for one thing, on a train
If
going
there
home
were
from
window
work.
cleaners, what? Oh, that was, I don't know what I
No,
was
but
trying to
no,
do like a
no,
German
it
accent
was.
doing.
General theory of relativity.
I know.
Yeah.
Because we did a whole episode on
Yeah,
this
but the
then.
special theory of relativity was just him on
Yeah,
a
the
train thinking about the speed of light.
I mean, what else are you going to do on a train?
Yeah.
I mean, you can only look at so much scenery, I would think. Eventually, you're going to start thinking about physics.
So, all right. So we know these magnetars now kind of exist. We have kind of a sort of a. I'm not going to say a theoretical framework because
Yeah,
that
we
hasn't
don't have
happened
enough
yet.
data
We
for
we
that
have some
to
ideas.
Put it in concrete.
Right.
Yeah.
And so, but what we do know of is there's 32 of these things, and they're out there, and they behave a certain way. They have very, very, very strong magnetic
Opinions.
fields.
No.
Oh, you're a magnetar. Liz the
You're
magnetar.
you're a magnetar.
Apparently my ideas are too strong for certain people, but anyway, because they have these really strong magnetic fields, they have a lot of flares. They erupt in X-rays and gamma rays.
I feel like we're just talking about gay men.
Gay men are magnetars.
Just a pride parade is what we're talking about right now. A lot
They're
of flares.
magnetars. That is awesome.
That
is awesome. So, if I ever go to a pride parade again,
everybody's drawn to them.
I think we should go as magnetars. And then people will be like, "What the fuck are you doing?" We're magnetars.
Yeah. Meanwhile, Chad is going off about
I don't know.
Skynet taking over. So.
Yeah, and there was something about chickens. Ron even has this
Robot
mathematical
chicken.
equation for chickens. I feel like that. Oh, that dude that we watch on Sundays when we watch YouTube. Anyway, they release just a vast amount of energy.
Yeah.
So let's talk about how much energy they release.
Yeah.
Let's go back in time.
Oh. Diddle, diddle, diddle.
2004.
Oh. Diddle.
All right, so this unfortunately has been become known as the Tsunami Day Magnetar event.
The Tsunami Day Magnetar event.
Yes, because 2 days prior was the massive Indonesia earthquake that caused the tsunami.
Oh.
Yeah.
No, why equate the two?
Yeah, that really was what I was thinking when.
Why? We don't need to.
Yeah, but I kind of get it. You want to. That was a major event that happened. And so.
All right, so they're just trying to. I mean.
So yeah, so on Christmas Day 2004, there was this huge, like one of the most intense earthquakes that happened on the Earth over in Indonesia. It created a tsunami that went around the Earth like 4 times or something, and it killed a lot of people.
Yeah.
2 days later, on the 27th of December, there was this massive flare that happens, and so now it is called the Tsunami Day Magnetar event.
Yet no people died from that one.
No people died.
Well, at least on this planet.
No, but so this flare was from a magnetar that compressed the Earth's magnetic field and rang it like a bell. And so the Earth's magnetic field gets compressed. It does these.
I've just seen it for home.
It does what?
It was just seeing if we're home.
Yeah. And so it compresses the Earth's magnetic field. And so as the flare recedes, the energy recedes, it comes back out. And so, but it continues to undulate like a bell. And so it rang the Earth's magnetic field like a bell.
How far away was this?
50,000 light years.
50,000 light years?
50,000
This Magnetars throws a tantrum, and Earth is like, hey, whoa, we didn't do anything to you.
And so the total energy that hit our magnetic field was equal to the sun's output in 150,000 years, total output. That
How are we still alive?
Amazing.
And also, we're lucky we have a magnetic field. Thank you, convecting core.
We're still on, right?
Yeah.
Okay. We just heard this sound.
I don't know what a desktop notification that was.
Yeah, and so basically the
chickens. It's all the chickens.
The chicken saved us. The supernova, not the supernova, the neutron star has a very sexy name, SGR 1806-20. And so basically what astronomers think happened was that this this neutron star, this magnetar, had a starquake. Had a little earthquake. So the surface of a neutron star is actually solid. You could stand on it.
Wait, I'm sorry. Hold on. Why don't I know this? What?
Yeah.
What?
So the surface of a neutron star is actually solid. And if you could somehow overcome gravity, well, or let's say that your bones are not going to be broken and you're not going to be compressed down or anything like that. No, you could actually stand on the surface of a neutron star.
I didn't realize that.
So they're solid.
God, now we need to do another episode on neutron stars because I'm just blown away.
Okay, well, in 2 weeks.
About.
So the surface is solid.
Okay.
You can stand on it. Neutron stars actually have atmospheres. It's a plasma atmosphere. That atmosphere is only 1 meter tall. So if you're standing on it, your feet are in the atmosphere. A
yardstick is 3 meters.
A yardstick is 40 inches, yeah. So 39 something inches. So we'll say 40. So it's 3 inches. It's 3 feet and 4 inches. And so if you're standing on a neutron star, your feet are in the neutron star's quote unquote atmosphere and your head is floating around in space. Yeah.
What? Is this the basis of the Little Prince?
What?
I just think of the small planet and he's just like...
Okay, sure.
Anyway.
All right, anyway, so there's a solid surface, and this surface is being really just affected by magnetic fields, by gravity. There's a lot of stress on this surface.
What is the surface made of?
Iron. It's usually iron.
Oh.
It is a little bit of the iron left over.
The core. It is the core, but it's the core and not just the plasma.
But it's not all of the core.
But it's some of the...
Because neutron stars are only, 12 miles across?
Yeah, they're... 15
miles across?
Yeah, they're small.
And so we'll say 10 miles across. And so it's not all the core of the core. It's not all of the iron of the core, but it is a little bit that's left over.
Left over from the... Wow. I can't believe I never knew that.
So this surface is under a lot of stress.
Hi, Katie.
It's under a lot of stress. Yeah. And sometimes, like plates on Earth, it will erupt.
Shift a bit.
A little...
And
so this is an example of what they think what caused it was basically a starquake on this neutron star. And so when
I smell a Quake video game expansion.
Oh yeah, well done. And so like on Earth, you have the plates that slip past each other. They do this big jump.
That's because we have tectonic plates.
We do have tectonic plates.
But interestingly enough, Mars has Marsquakes, and Mars does not have plate tectonics. It does not have the plates of surface that shift around.
Right.
But it still has...
They're pretty much frozen in place at this point.
It still has quakes.
So they think that the crust of this neutron star moved literally 1 centimeter.
It was just
1 centimeter, and it produced enough energy to equal the sun's total output for 150,000 years to compress our magnetic field, to blind satellites that were in orbit around the Earth. That some satellites saw the reflection of this off of the surface of the moon.
What?
Yes.
Was there any physical effects on the Earth or on
no? It was
people?
just that
We were just we were protected because of our magnetic
because of
field.
the magnetic field.
It was like a buffer. It's a buffer, and it acted like a buffer.
Exactly.
Wow.
If this was an earthquake on Earth.
Oh, look who's joining us from Colombia? Wherever? Did you make it past immigration?
Oh, yeah. Bogota, I bet. He could have been in a goddamn podcast. Anyway. So, all right. So, the most powerful earthquake we've ever had on Earth was 9.0, right? It was 9.
Was that the most powerful one? Where was that one? Was that the tsunami one?
I don't know.
Oh, okay.
Anyway, for Medellin, all right, be careful over there. For if this was an earthquake on Earth, it would register as 23 on the Richter scale. It would just...
The Richter scale, if you don't know...
is logarithmic.
It goes up to 10.
Yeah. But I guess technically you could...
I guess you could go further, but...
go much further, but it's logarithmic. So an earthquake of 10 is 10 times more powerful than 9.
Yeah.
11 is 100 times.
3. Wow.
That is an earthquake that would be felt all around the world. So, yeah, I mean these things are really quite insane.
I mean,
they're fascinating. They're fascinating.
And that's just the universe. All the crazy, insane, fascinating, wild things that are out there. And it's not like, I mean, sure, I'm sure magnetars are rare or rarer than neutron stars and black holes and stuff. But the fact that, I mean, there's, I'm sure, a plethora amongst the hundreds of billions of galaxies.
Yeah. And you know the thing is this event, gotta take a drink. Dog bark.
A dog did bark. Oh.
Was that Jack?
Why did my iPad go to sleep? Oh no, my connection was off. Oh.
Anyway, everybody take a drink.
Jesus. All right, hold on. I can do this. I can figure this out. Oh, there it is. Ah! I don't have any more drink. I gotta.
Well, here. Okay. You want to have mine?
No.
Have some of mine.
Okay.
That way you can see you drink. All right, so this was 50,000 light years away. By the way, the center of the Milky Way galaxy.
I'm always lively, Ron.
The center of the Milky Way galaxy is what? 26,000 light years away?
Sure.
So twice the distance from the center of the galaxy. If it would have been 5,000 light years away, it would have caused problems for us.
5,000 light years?
Yeah.
That's far, but
not
far enough.
Yeah.
5,000 light years?
The closest magnetar, 7,000 light years that we know of.
Yeah, see, that's... but, I mean, there's no... Oh, no, because... Well, no, there's no... Is there a star close enough that could go supernova to turn into a magnetar?
Betelgeuse. I think Betelgeuse is closest.
Betelgeuse is 600 light years away, but it's not... There's no evidence that it could become a magnetar, that it would just become maybe a neutron star.
Right,
Do we know Betelgeuse's endgame?
But we don't know... We truly don't know the mechanism that causes such strong magnetic field.
Right.
So any supernova could create potentially a magnetar. So Betelgeuse could do it at 500 light years away. We're fucked.
Now I don't want Betelgeuse to explode, but I want it to explode, but I don't want it to.
Okay, but here's the thing, though. Remember, though, Okay, so this energy, there's a starquake. It's not like this energy just gets shot out in all directions in space. It's very
it's
specific
isolated
direction.
to where the quake
Yeah.
epicenter is.
Yeah, and so we could just be, it could happen and just obliterate fucking Mars, you know? And so you just kind of have to be, I know.
The rovers.
I know, right? And so you really just kind of have to be. It's like it has to shoot. Okay, I don't want to use that. I don't. There's too many Americans using guns. It has to be aimed in our direction. And so so there is that hope, and the chance of that is very slight. It's not zero, but it's very slight.
Is anything ever zero?
Nope.
Other than absolute.
All right.
Brandon says usually a thunderstone will create a magnetar. Otherwise, it's just a Vaporian.
Exactly. That's all we need, right? All right. So anyway, all right. We have a point of order. Remember, kids.
If one of his comments causes a spit take. Have we ever spit taked on this?
Have we what?
Have we spit taked before?
Oh, we have had to have spit taked. All right. Anyway, there are a couple of ways in which we're trying to search for these things to kind of understand them a little better.
Because, I mean, yeah.
We are using gravitational waves, so LIGO. To try to better understand neutron stars and so forth and so on. The International Space Station has the NICER on it.
Oh, that's nice.
Yeah, Neutron Star Interior Composition Explorer, also known as NICER.
Wait, where's the R come? Oh, the ER for... They really stretch those acronyms. They really are pretty liberal with those.
Anyway, it was installed on ISS in 2017. Its specific goal is to determine what's inside of a neutron star, which will give us a better understanding of magnetars.
Wait. We don't know what's inside of a neutron star yet?
No. We have...
Isn't it neutrons?
Well, I mean... Yeah, okay, at some point, yeah. So with a neutron star, what happens is...
Wait. I'm sorry. It's a solid... It has a solid surface you could stand on, but then there's more inside of that than just being solid iron. God damn it, we're doing a neutron star episode now.
We're doing a neutron star episode. I do think that in 4 weeks we do a neutron star episode. We'll just start... What is it? Oh, shit, it's manned spaceflight. God,
right, Ron, I made a 69 joke on a team huddle for work once, and I didn't. Everybody laughed.
All right. Okay. So I do think at some point in our episodes for the year, we do change it over to neutron stars, because all right. So what's with neutron stars? The gravity is so intense. Yes, there's a solid surface on a neutron star, but as you go down into it, especially down into the core, the gravity is so intense. Everything is so intense that in some cases, electrons just get shoved into protons and they become neutrons.
It's like a mosh pit.
Yeah. And so these, in our everyday world, electrons are spinning around
like
the
Tokyo
nucleus,
subway.
But the gravity is so strong that the electrons just can't overcome what's called the Pauli exclusion principle, and they just get shoved down and absorbed by the protons and become neutrons. And so it's...
yeah, I knew that part.
We're doing an episode.
Okay.
We're going to do an episode. But anyway, so there is...
wait, no. Jack says, according to Marvel, the insides of neutron stars are made of Uru, so it's like Mjolnir.
Yeah, that's exactly what it is. I mean, we get it from the heart of the neutron star.
Or Mew Mew. Mew Mew.
And so this is on ISS, and it is meant to...
Sounds pretty nice.
Exactly, right? And it's enabled astronomers to make more accurate measurements regarding basically the size and density parameters of neutron stars.
I guess every time we do an episode,
Your mind's blown?
Well, yes, my mind is blown. I like to think that I'm fairly literate in astronomy, knowledgeable in astronomy. But yet at the same time, I'm like, wow, there are so many things we don't understand, or we'd have just a base like, yeah, there's magnetars, but we don't know really anything about them. They're there, and they're holomagnetic. And I don't know what voice this is, but it's what I'm doing for comedic purposes right now.
But that is what is so cool about physics and astronomy.
Yeah. That's what it's exciting, because it's like, oh, look at the things we know, but then look at all these things we don't know about the things we know.
Yeah, and what I find fascinating...
Take all my tax dollars, build all the technology to understand this.
Is in the second half of the 19th century, the late 1800s, after Maxwell, James Clerk Maxwell... Are you cutting me off?
No.
Oh, okay. Came up with the theory of electromagnetism, and it gave us
light.
Unified.
Let there be light.
Yeah, exactly.
That's the real let there be light moment.
It gave us, at least at the time, kind of an understanding of what light was, and so we had electromagnetism, which explained everything almost that we could see that was not gravity. From friction to the light coming from the sun. And physicists really thought that at that point physics was over.
We're done, folks. We explained
done.
light. We got light down.
Take
that, Bible.
Done. We are done. In fact, there was a quote from a physicist whose name was lost to history. So that shows you how much contribution they made. Except for this one statement was, physics is over. Physics will now become, go the way of botany, and we will just classify things. Yeah. And then 1905 happened. And so it's just, what happened in 1905 was quantum physics, and... There's
a smaller world, you guys.
Yes, exactly.
Call Paul Rudd.
And then 12 years later...
We got a new movie to promote.
The general theory of relativity. And so our understanding has just gone insane. And even with... So we do not understand fundamentally...
99.9% of the universe?
1% of the universe. We understand 99% of the universe.
I don't know. It seems the other way around.
No. Actually, no, you're right. We don't... okay, I see what you're saying.
Yeah.
It's dark matter, dark energy. We don't understand 95% of the universe. Yeah. But we can make predictions based on what we do know, with some of this stuff. And it's just... It's fascinating, the shit that comes up that we're like, I don't fucking know. We just don't know what is going on, and this is one of these
magnetic stars that are remnants of stars that are basically not even stars. They're just dead stars.
They're dead stars.
They're dead stars that can cause a lot of havoc.
And you know what? There is an implication to this, is that there's these things called fast radio bursts. And FRBs. And it's where we get this really quick spike in radio waves.
Aliens?
What?
Aliens?
Or magnetars.
Oh, okay.
In fact, in April of 2020...
Aliens riding a magnetar?
They're standing on it, yeah. There was a fast radio burst that came from a magnetar, a known magnetar, SGR 1935 plus 2154.
Known magnetar.
Yeah, and so now they're thinking that magnetars are related in some way to fast radio bursts.
What are FRBs related? I thought they were related to what are they, quasi-stellar objects?
Quasars?
Quasars.
Yeah. Well, that was because originally they thought that all fast FRBs were extragalactic, but in April 2020,
intragalactic FRBs.
Yeah, in April 2020, SGR 1935 plus 2154, so sexy, is in the Milky Way. and that shattered that thought.
Oh, okay, all right, yeah. All I need is one piece of
data. One piece of data. That's all you need. So you need infinite pieces of data to prove a hypothesis, but it does get to a point where you can do.
You have enough
theory.
Where you're like, all right,
it's good
like
enough.
We got one piece of the puzzle missing, but we got most of it. We can tell it's a moon.
All it does is take one legit piece of data to where you then say that contradicts a hypothesis or a theory, and you have to either amend your theory or throw it away.
Yeah, and that's how science works, people.
But I know, right? In May 2021, the Hubble Space Telescopes announced that 4 FRBs coming from known magnetars.
Wow.
Yeah, so that could explain the fast radio bursts that we see. And these are like where like the radio intensity of an object just spikes over a millisecond and then kind of fades away. What I have.
I mean, is that like related to where us being in line in a certain way with the magnetar, like with the pulsar, and we're seeing some sort of
probably if it does come from I mean, it's probably the alignment thing.
Like we have to be in line with to see.
Yeah, I mean, it's just these objects are just insane. And, this is the shit I love about astronomy, where we are now at a point in our knowledge of the universe where, stars that don't concern us in that, oh, that's weird. This star is weird.
Weird stars.
Weird stars.
Look at Hollywood. There's weird stars all around.
But this really esoteric. I mean, we're on the extremes of physics here, and that is what is, just fascinating in physics right now. Is that our knowledge has gotten to a point where, it takes extremes to really. I don't know. It's like it's not ho hum. I mean, everything is ho hum. I don't because I've had drinks and I did pre-game a little bit. I can't articulate an actual sentence, but this is the shit. This and like some of the black holes that we're seeing and some of this really just on the fringe of stuff is just absolutely fascinating.
I agree with you. Meanwhile, chat's having a discussion about chicken nuggets.
About what? Chicken nuggets? Oh, they're good.
I know. You know what? Chicken nuggets were referenced yesterday, and I've had a chicken nugget craving ever since then, and now it's not helped because everybody's talking about chicken nuggets.
When did we?
I don't know where.
Who referenced chicken nuggets?
I don't know.
I didn't reference chicken nuggets.
I know.
Hogwarts Legacy?
No, I don't know where it came from. There was something about chicken nuggets, and now...
Okay. Wait a minute. I hear chicken nuggets.
And then
I look to the chat, and the only thing I see is cocaine.
Small amounts of added cocaine. No, you don't need cocaine. You just cut them like the dinosaurs. You just make them different shapes, and you're all there.
I think it's great that we do have them as dinosaurs because chickens are little dinosaurs.
They are little dinosaurs.
Anyway, I think we should call it.
I think so too.
All right.
It seems like hangout territory.
Oh, we're
hangover
definitely
territory.
Oh, you did it! You did it! You did it, Brandon. She did it. She did it. She called it hangout. This is
because of you two.
No.
This is because I blame you and Brandon for getting hangout.
All right.
Starting it.
So I'm sure you guys already know this, but Brandon and I would call it hangout. Exactly, it happened. We would call it hangout just to get the reaction from Liz.
Oh, meanwhile, Brandon sent a picture of what he's eating.
Oh.
Brandon, I'm going to share what you're eating. This is what... Oh, God. See the ring light's in the way.
Oh, there's no way you can... Oh, you're just ruining it. You can't do it. Back away. Back away.
It looks delicious, Brandon. Whatever you're eating.
Anyway, guys, thanks for joining us. Please stay over for the hangover.
Hang out with the hangover.
Hang out with the hangover. There are a couple of things that were in the news that I do want to talk about in the hangover.
So
it
I
will
guess,
have some structure.
but otherwise, fall into our Magnetar pit trap.
Well done. Well done. Thanks, Kurt.
Listen to some Nirvana.
Thanks,
and think
Kurt.
about Magnetars and how one that is,
All right. Anyway, join us in a couple weeks for an episode of High in the Sky, and we'll leave all this esoteric physics shit behind, and let's just take a look at what's in the sky. We need to show your mom Mars and Pleiades tonight.
Okay.
Anyway, thanks for joining us. See you in a couple weeks. Stay safe, stay healthy, and vote blue. Cheers. Bye.
Bye. Be right back.
And we're back.
For the hangover with Cosmos. In the original episode, we're talking about Magnetars, and there's been multiple of the same Nirvana references.
Ron's, he's... Oh, wait a minute. Is it?
Oh,
Oh,
he's
no, it
microwaving
is.
some dinosaurs. He's got some dinosaur. You got some dinosaur chicken nuggets, Ron? I mean, you have two small. No, they're not small anymore. Your kids, I'm sure they're old enough to eat dinosaur. Everybody's old enough to eat dinosaur nuggets.
Oh, yeah, his kids, yeah.
Yeah. If you're just checking out The Hangover, go watch the main episode or listen to the main episode. There's a lot of chicken nugget talk.
In the chat.
Which is surprising with an episode on Magnetars. But Magnetars...
I mean, at the end of our episodes,
I was trying to think of a dinosaur that ended with a tar, and I couldn't think of one.
Sagittarius. No, that's a constellation.
Centaur. That's like a magnetic centaur referenced. That's a centaur archer.
Fuck it. I can't do it. Anyway, all right. Welcome to The Hangover, where who knows what we're going to talk about. It's kind of like the end of the main... Oh, she did it! Katie gets $5.
It happened. I just spilled on myself. Damn it. I was really doing a good job during the main episode. Of course, The Hangover.
Oh, well, no,
it's just dripping.
It's
just dripping now. Okay, it's just, let me wipe it off on my space leggings.
Katie gets the $5. Katie, I'll make sure she sends
I don't know. Reptar. Okay, I'll allow Reptar. Rugrats. I hated the Rugrats.
All right, now.
Who's giving you that $5, Katie?
You are.
No.
Yes. No, you are. You took the bet.
No, because I knew that there was a high... I know myself. I know there's a high probability I'm going to spill on myself. Are you kidding me?
Oh, my God. Now I have to give her $5 on your behalf. Buy something from Wildixia on Etsy. Anyway, all right, so here's the thing. Okay, so I actually had this in the main part of the show, but then I was like, nah, we're going to put it in Hangover.
Oh, okay.
It's the two things that hit the news this week.
Oh, that hit the news this week.
Yeah, one from James Webb Space Telescope.
Okay, this one I didn't actually read a lot about this. I really don't.
Right, and so
I haven't had a chance.
Astronomers were looking at some of the initial data dump from about a year ago. In July.
Dump. He said dump. I'm almost 40.
I know, we're all middle school, aren't we? I mean, the world would be much better if we just all admitted that. Okay. So anyway, there was this data drop.
Okay.
Back last July or whatever it was. This is the first images. Mm-hmm. And so... astronomers have been able to kind of dive into that data a little bit.
Which image set?
This is the galaxy. So this is the deep field.
Oh, the deep field. Okay.
Yeah. And so what they noticed was that some of these galaxies were red in color. So these have, well, yeah, but also the combination of these could also have older stars in them.
Right.
And so... they did a little bit of, data analysis, and these galaxies are coming to us when the universe was 500 to 700 million years old.
That's young.
Very young. Okay, so that is not necessarily an interesting thing, because there are galaxies that are starting to form at the 500, 700 million year mark. Okay.
So they're like, oh, this is normal.
And so, yeah, so basically in the evolution of the universe, you had the Big Bang. And then at 400 million years or so, you're coming out of what is called the dark ages of the evolution of the universe. And this is when...
you get light.
Well, you have light at that point. Okay. The universe has become transparent, not opaque at that point.
Oh, okay.
And so light is freely flying through the universe. But what you don't have is you don't have the star formation that has occurred in the dark ages. It's just energy and matter, but that matter hasn't coalesced into stars to become galaxies. Okay. And so it's considered dark.
Yes.
You can't really see it.
That's what I think that's what I meant was when we had light, it's the star formation.
Yeah. And so at 500 million years, you do have a lot of stars that have formed, and they are coalescing into galaxies.
I don't know if you know this, but then I just was thinking, okay, 500 million years, this is what's happening. after the Big Bang, then what's happening 500 million years after the formation of the Earth? Like, just a little comparison of...
Oh, I don't know what's happening in 500 million years.
Yeah.
I
mean, it's...
anyway,
off topic.
I do
That's
think there's probably life at that point, but it's microbial.
Yeah.
But anyway. So we do know that there's galaxies 500 million years after the Big Bang, but we have always assumed they'd be small because of our understanding of how galaxies form is they start small and then galaxies coalesce through galactic what?
Cannibalism.
Yes, and become bigger galaxies. But these galaxies that we're seeing 500 million years to 700 million after the Big Bang are as massive as the Milky Way. And that is not...
normal. That's not expected.
That's not expected.
That's unexpected.
That is not expected.
That's a lot of star formation that then shouldn't have had time to happen.
Yes, but more importantly for me is that what it means is we don't fundamentally understand how galaxies form. Which means...
I thought we already knew that we were like, we don't really know how they form. We're just kind of shooting in the wind. We're just guessing.
But there... Okay, so if you look at, there is a lot of evidence for smaller galaxies coalescing to become bigger galaxies.
It makes sense.
There's a lot of evidence for that.
Just logically.
Yeah, and so there's a lot of evidence for that. But I really do love for our current knowledge to be kind of upended, and this upends it. Now, to be fair... There could be some analysis that comes out that goes, okay, so this really didn't happen 500 million years after Big Bang, and this actually kind of does fall in line with our understanding. But as it stands right now,
it's like wait a minute.
Yeah, so they from our understanding is that we really should not be seeing anything the size of the Milky Way. 500 million years after the Big Bang. And
when are we supposed to see things like the size of our galaxy?
I mean, because you need time for these smaller galaxies to form, and then you need them to coalesce.
Come in contact with
and
each
so
other.
at least a billion years at the earliest. And so this really kind of moves it down, and so we don't understand fundamentally what is happening. And that is just an amazing thing to me, is that I love, maybe it's the inner punk in me with that really kind of wants to upend things, and this really does upend our understanding of things.
It's 100% that.
Okay, I'll give you that. But this also falls into that. The next thing also falls into that category.
Well, hold on. So, it just maybe things... then happened quicker. Things formed quicker.
Yeah.
Than what we thought the rate was for star formation and all that. And it just pushes.
and
pushes
there's
the timeline back.
There's nothing wrong with that. It's just that we need to understand what the process is to do this, to create a galaxy that is the size of the Milky Way, maybe even a little bit bigger, that from our understanding of how the universe works should not be there.
And this is the benefit of telescopes, even though it's so over budget and so took so many extra years to get up there, that we're seeing why it's beneficial, why it's worth it.
And this is from the initial data drop.
Because this is just the first look, like, oh, we've turned it on and we've looked at something, and then we're getting already these revolutionary data sets that are making people go, oh, we don't understand anything.
All right, well, okay.
Okay, I know. I was a little. I mean, I'm being.
Yeah. But let's be honest. This is what James Webb was designed to do. And
you're making me hungry, Ron. You're making me hungry.
We're not even a year away.
Yeah.
From the mirrors actually being fucking aligned.
Yeah.
We're not even a year away from we're just a few months away from the anniversary of the first data drop.
Mm-hmm.
And we have discovered stuff that have fundamentally made us go,
wait a minute.
Yeah, and but this is what James Webb
was designed to do. It really was to kind of, not intentionally to upend things, but just so we could see and understand more and refine our current observations to be like, oh, wait.
Yeah. So this is the dream of every observational astronomer or observational physicist, also known as an experimentalist.
Those are the ones that look at things instead of just do math
and measure things and things like that.
Yeah.
Their dream, they have two dreams. One is to provide another string in the tapestry that supports a theory. So that is just another data point that proves that a theory is correct. But also, this is the punk part.
To destroy the tapestry.
To set it in the fucking fire.
Create a whole new tapestry.
Exactly. And this is one of those things, though, this is one of those things where we don't throw away the theory, but rather we amend it, that we change it. And so, the experimentalists are like the real punk rockers of physics.
Because the experimentalists are the one that are doing the experiments and stuff, whereas, and everybody else is like, well, based on math, it does this thing. And the experimentalists are like, let me put your math to the test. Let's look at some shit.
And this is coming from a person who was a punk at heart, who had dreams of being a theorist.
It's like Copernicus versus Galileo. Copernicus was like, hey, here's how things should be. Here's, then Galileo or Kepler was like, here's the math behind it. And Galileo was like, hey,
Kepler's probably the better.
Here's what I see. I see this happening. So this must be, I don't know why I'm going very Southern in this episode.
That's okay.
It's my go-to accent is Southern. Bernie says burning the galactic Elden tree. For you Elden Ring fans out there.
Yeah. Oh my God. Liz and I are playing two games right now. Elden Ring and Hogwarts Legacy.
Hogwarts is real fun.
And if you're playing Elden Ring,
Katie,
you almost need Hogwarts Legacy.
Katie, if you want an Xbox One, let me know.
Oh, damn it. I was going to try to sell it.
Kirk Pernicus.
All right. So the second bit of news.
You should make a new character with that name. Anyway.
The second bit of news is not James Webb related, but will be. So, all right.
Okay.
So, this actually comes to us from the TESS spacecraft.
TESS,
which is
the extra. No.
I don't even know.
It's for exoplanets.
Yeah, it's for exoplanets. Okay. And so what TESS is doing...
Con Brian.
No! Oh, no, what is it? Con! Anyway, so TESS is looking at all these stars, and it's measuring its brightness, and it's basically looking for dips in brightness, which means an exoplanet's passing by. So it found this planet. So it looked at this star. TOI-5205.
Okay.
It's the 5,255th star in its little thing of looking at stars.
Okay.
And so
I am a Ravenclaw. How would you assume a Slytherin? Excuse me. I am a Gryffindor. I am a Gryffindor.
No, you're a Ravenclaw.
No, I am a Gryffindor, but I have chosen to play as a Ravenclaw in this game.
She did.
And their common house has stars and astronomy all over the place.
And I wish I was a fucking Ravenclaw now.
I am now a Ravenclaw convert.
Yeah.
Slytherin.
So I'm Gryffindor. I'm Gryffindor.
I almost said Slytherin, but I can't.
I was straight up Gryffindor.
I said when we started I was going to be mean and go Slytherin and be like a dick through the whole thing, but then I'm just nice and I can't do it.
Yeah, so I was straight up Gryffindor in this. Liz actually was straight up Gryffindor as well, but chose Ravenclaw. And now I wish I had chosen Ravenclaw just by the fucking room, common room.
Yeah. Anyway, back to Tess.
Okay, so Tess is looking at this star, and this a little exoplanet goes in front of it.
Oh.
And since this exoplanet passes in front of it, the light of the star drops. It drops 7%.
Oh, your Patronus is the bad. I can't remember my Patronus is when I did the Harry Potter online, the little thing. I can't remember what mine was.
All right, so it dropped 7%, which is the deepest drop that we've ever seen.
Drop, so that must be a big planet.
Yeah, so basically this exoplanet has basically almost blocked out 10% of this star's light.
Wow, that's big.
Okay, so automatically thinking really big planet.
Yeah.
This planet goes around the star in like 1.5 days.
So it's super close.
Super close.
So is it a super, super hot Jupiter?
That's what it is.
It's a super, super hot Jupiter?
It is a planet which is about the size of Jupiter.
Uh-huh.
Okay, we've seen plenty of this shit.
Yeah, which is weird, though. It was weird for us to find Jupiter-sized planets so close to the sun because it was assumed based on the model of our solar system that during the formation of the solar system that those larger planets would have moved outward to be further away because closer to the sun, you shouldn't have those gases. Those gases should be stripped, or they shouldn't exist at that high temperatures, or
or you can start at the very farthest reaches and fall in. You actually can kind of move it. But what is fascinating about this, and what they are terming as the forbidden planet, which makes me think of something that Ron said to me earlier today via text of Forbidden Planetarium. But anyway, the forbidden planet. Is that this, the star, is only 4 times bigger than the planet. Yeah. 4 times bigger. So.
Wait, that's not. What?
Yeah.
How?
So,
what?
Okay. So this is a small, what we call M dwarf planet. Star. So it's a very small red dwarf star.
How did it get a planet so big?
We don't know.
This is what I'm talking about. We think we know something, and the universe goes, "Hold my beer.
Hold my beer. Hold my drink. Let me show you something."
Beer.
So this is a planet that is 4 times smaller than its star at a very small distance from it. Where we're talking probably 10% the distance between between
Mercury,
the sun, and Mercury. So we're probably talking 3 million miles away from the sun, 5 million miles.
But how far out does the sun's corona extend?
Oh, that's a fucking good question. I don't know.
Google it. Chat, Google it right now.
Katie's already done it.
Somebody Google it.
But anyway, so this is a planet where right now astronomers can only say, we don't know why it should be where it's at. Or
you know what? I would say, look. I'm sorry. I know you. I just want to say it's refreshing when there's somebody in a professional field that can be like, we don't know.
Yeah.
Time will tell. Data will tell. We need more observation instead of just trying to make up a fucking answer.
Yeah, and
to appease public minds or whatever, their own mind.
Yeah, it's really their own minds, but
That's wild.
It really is wild. I think
the sun's corona is out to 1 million miles out from the sun.
Oh,
I want to say it's
probably.
about 1 million miles.
Yeah, it's a corona with lines refracting. All right.
42 star units.
Exactly. So, what is this planet that we know exists? This is a planet we know exists. It has been proven to exist. It's not like these things are announced to the world without some sort of data to back it up.
They don't just announce it before they.
Yeah, so there has been some proof to this, and so we know it exists, and it is a quarter the size of the star that it goes around, which is unheard of.
What's the minimum size for a brown dwarf?
Oh, shit. I think it's like a few times the size of Jupiter. 8 times the size of Jupiter.
Okay, and this planet is about the size of Jupiter.
This is about the size of Jupiter, and this is a true
so this is just a
star.
real This is a small ass fucking
42
star.
star units again. So this is a small star. This is one of the smallest stars you can get.
And
I think it's something like 10% the size of the sun.
And a Jupiter-sized planet formed that close to it? Or maybe formed farther away and migrated in?
And maybe migrated in.
Because if it has such a small gravity, being a smaller star...
That its far enough awayness is much smaller than like for our suns, if that makes sense. I've been drinking, so
I understand what you're saying. What you're saying.
Yeah, so
you used a word that wasn't a word, but I understand.
This is truly an exoplanet that really, from our understanding of how exoplanets should form, is fucking weird. That we don't understand it, and like you said, it is just refreshing. It's an amazing thing in which. And, all right, here is how you can tell a true scientist from somebody who's a poser, is that...
poser. Thank you for bringing back the poser term from the early 2000s.
Well, yeah, I'm a punk, so posers are part of our culture. Anyway, so is that if a scientist will say, we don't know, versus somebody who tries to explain it away somehow.
God did it.
God did it. It's intelligent design for whatever reason. God put this planet here.
This is how it is.
Yeah, and so, I mean, it's just, it really is a refreshing thing when you do have somebody that is adult enough to say, we don't know. And I realize that in our culture, we are under the impression, we are under the pressure to say that we do know something.
I think it's just a human psychosis. Is like we need to understand things, and we can't handle it when we don't understand something, especially if it's like, I don't know. We just in our psyche, our brains have evolved to a point where it's hard for us not to understand the why of something. Like all 2-year-olds are asking why, or 4-year-olds, whatever age they start talking and know the word why. They're asking why for every single fucking thing, and that's just part of we need an answer, and so it takes a bit of a stronger mind, or I don't want to say stronger mind, but I want to say just maybe more.
No, I think a stronger mind. I think a stronger mind.
I don't know, to then accept when you don't have that answer, when you can't explain something, even though it makes you maybe uncomfortable to not be able to explain something or not have that answer. And that's the point of science, and science is all about really getting answers, but also not having any answers at the same time.
Can you stop hitting the mic?
I can't. Look, it has the thing around it that's supposed to shock absorb.
No, that's true. But I do think that in today's world is that we do understand so much.
With an I, Mom. With an I is the correct spelling.
We do understand so much about we understand the world around us
so much that we think we should be understanding all of it.
Exactly.
But we don't understand.
So we really are falling into this 1880s trap where we are like, we understand everything. Everything now is botany, where we're classifying things. So that is not the case at all. The universe is forever going to present us with a situation, an object, whatever in the universe that really challenges our view, our understanding of the universe.
Do you think we'll survive long enough as a species to understand everything? Or will everything be ununderstandable? Will there always be more to understand or to learn?
All right, I think you have two things in this question. I think fundamentally, eventually, we can understand the universe. Okay. That might be hubris, but I do think that we fundamentally can't. The laws of physics are the laws of physics and don't change. And so we just need to understand the mathematics to be able to understand the laws of
and
physics.
Put the funds into the technology
Yes,
that we
and
need.
I do think that we will get there. Whether or not we will survive long enough to get to that is a different question. And I do think after
we have at least 2.5 billion years before the sun starts to take us out to figure it out.
Well, yeah, okay, and I do
on.
think that we could do that, but I do think that given by something that happened earlier today, I don't think that humanity has much.
Wait, shh.
Oh yeah.
Wait.
Jack is dreaming.
Let's see if we can hear Jack dreaming. Shh. I was not doing it.
No.
Okay.
But anyway, I don't have a lot of hope with humanity being able to survive long enough to do it. And I do say this, in all honesty, without comment any further, if father and son can't come together and at least admit that the differences that we have between us are really quite petty, and then instead let it blow up. If we can't have a father and son do that, then there's no hope for the larger humanity to do that.
It just takes one question. WWJD.
Well, in all honesty.
But hold on. No, I do want to say Ron's comment. Ron says, sadly, we have no control over the well, he said earlier, honestly, I think our vulture trains us to worry. It trains us to worry about the stories we imagine other people tell about us. And then he says, sadly, we have no control over the vulture, but we do control our human culture, and we can do better, and we need to. And that's 100%. We can do better.
We can do better.
I mean, we're children. We're still children. We're 2-year-olds running a planet.
Yeah.
It's really really what our humanity is. We're 2-year-olds running a planet.
My shirt, what would Ron Proctor do, is like in a container back in Utah. But
and I
anyway,
really hope the future leaders of the world that they are paying attention and become politically engaged before they can vote.
In all
I
honesty,
hope that's true for most.
In all honesty, I need to reach out to my dad now and all right. So
are you gonna olive branch it?
I'm gonna olive branch. So my dad and I had a little bit of a contentious conversation today, and it basically started with politics and devolved. And so now I have to be the adult and reach out to my dad, and maybe my dad will be the adult and reach out to me. But anyway, and so there's no hope for humanity if we are fighting stupid fights over, in all honesty, things that don't matter. Because at the end of the day,
land grabs.
At the end of the day,
control, power.
But okay, so those are really extremely important.
Those are not tangible things that aren't real.
But
money, money's not even tangible anymore. I mean, it's
okay. So my dad and I are fundamentally not ever going to agree on how, like.
Just tell him to think of Jimmy Carter.
He voted for Jimmy Carter.
Yeah, so tell him.
He voted for Jimmy Carter.
What would JC do?
What would JC do? If I were to send that to my mom, she'd be like, "What the fuck does this mean?" But anyway, so I think, like, for me and my dad, we fundamentally disagree on some stuff. And it blew up today in a conversation which Liz had to listen to. And she was like, oh my God.
I was doing my hair in the bathroom, given this little wavy curly you see going on here with my new haircut.
But she was like, literally, oh my fucking God.
Like, oh my God. It was entertaining to listen to until it ended.
Yeah, and it ended up abruptly on my end, on their end. But anyway, and so if like me and my dad can't overcome this, how are we and Putin going to overcome this?
Putin's not overcoming anything because Putin just wants
the
power and control and riding horses shirtless. Apparently, is the thing.
The thing is like, so for me, I can go to my dad later and go, hey, look, I can be the adult in this and say, I'm sorry we got to this.
Papa, can you hear me?
Realizing that my dad is almost 80 years old and that his fundamental view of the universe is not going to change. And so it's like I need to step up and say, okay, I'm not going to talk about this until your funeral. We're going to bring all this shit up. I'm not going to do that. I won't do that. But anyway, Putin was like, I'm just going to lob a nuclear bomb at you. And so, long story short, is I don't have hope in humanity to last long enough to figure it out. Wow. I hope so. I really hope so. It is the optimist in me that really holds out hope that somebody is going to just overthrow Putin. The world become a great place, and nuclear weapons will go away, and that we will not destroy ourselves.
We might just need to start over with the few remaining people on Earth after the nuclear holocaust. We might need to start over.
But how long did it take us from the fall of the Roman Empire to
the Romans? Anyway, I'm sorry. I was going to make an analogy,
so you had this cumulative knowledge. You had this cumulative knowledge that basically progressed.
And what got to the Roman Empire? Greed.
Well, okay. Just beyond that.
Greed and power.
You did, yes, but you did have this cumulative knowledge that came
ended up being lost.
That became lost with the fall of the Roman Empire.
And the burning of the Library of Alexandria.
And led by, exactly. And so if something were to happen, we have to start over. So quantum physics goes away. General theory of relativity goes away.
Yeah, we definitely do have more knowledge that can benefit us now than the Romans had, than earlier civilizations had that experienced, basically just destruction or whole wipeouts of whatever. I'm sure there has been so much loss to time and whatever that we don't even know about. There's so much buried under the ground that we don't know.
Yeah.
And realize, we don't realize the extent of knowledge of a lot of ancient. The Romans, they did aqueducts. They had apartments. There was a lot of
ants have air conditioning.
Ants have made their own air conditioning. There's a lot. There's a
lot to life.
We don't know how much has been lost to history before us from whatever extinction events or whatever has happened.
How many Einsteins have we lost because of social circumstances?
Right. Yeah.
I'm looking in particular at
this is
Africa.
The part of the Hangover where we get.
This took a turn. Africa, India, Southeast Asia. How many Einsteins have we lost?
Right. How many Einsteins have not had the opportunity? Have the opportunity to contribute. To use their intelligence who have been forced to go and do other things or be a part of things that have made them criminals or had been.
We have Albert Einstein because he was able to sit in a patent office, and those patents made him think.
If you look
strategically,
and if you look at all the contributions in say just recent science, it's all like white guys, white older guys. How much knowledge? How many contributions have we possibly lost from women, people of color, people?
Exactly.
It's unimaginable because
we
don't.
We're not too far away. In all honesty, in history, we're not too far away from guidance counselors in high school telling girls that they need to not think about science and instead think about teaching,
Right.
nursing,
Yeah.
the stereotypical.
I mean, for me,
No, go ahead.
I don't. Oh God, I don't even know if I even went to see a guidance counselor in high school. Like, I have no memory of that. But for me, I never thought like I'm not great with math. Math is harder for me. I have to think longer for it, which makes me kind of just shut down. My brain just kind of like shuts down, and then I rely on other people to do it for me. You know, I mean, I can do it eventually, but my brain is wired in a way where it's harder for me to understand the connections. It doesn't
Right.
come as easy to me because it's a different pattern of thinking, I think, you know. And so like I didn't think I could go into like anything like being an astronomer, or because it's so math heavy or anything like that. I never thought about that as being a career,
Right.
you know. And so I
Right.
really didn't know what I could do, you know. I mean, I eventually settled on becoming a history teacher, which never ended up happening because I loved history and I can understand and interpret that and translate that, and it's interesting to me, you know. But I didn't really. It's kind of like the things that were harder for me, I never really had that encouragement or like, no, you can do it. It just or anybody to show me like different paths of taking to fulfill that or to fulfill different things, you know.
Yeah.
Because, you know, I'm a girl, so it's like, you know, being a housewife or, you know, doing things
Right.
that are more associated with what women do, you know. It's not, and this is me being, you know, I graduated high school in 2003, you know, which is not that long ago, but now I guess is that long ago. You know, it thinks like, I feel like
Yeah.
we should have been a more...
Yeah, so I
don't know what I'm
graduated. I graduated in physics from Clemson University, December 1996.
Mm-hmm.
There were 2 members of my graduation class. There was me and a guy named Andre.
Mm-hmm.
The years before, it was just dominated by guys.
Yeah.
The next graduation class had 2 girls in it, I think fundamentally at that time, girls were just dissuaded, and it's not just guidance counselors. So I don't want to say it's just them. It's just
there's no promotion for it. There's no like, hey, you can do that. Now I see a lot more females in STEM that I'm like, oh my God, this would have been amazing if I was younger.
Yeah,
to
and
see
so
this.
that's why like you do have like with the Event Horizon Telescope project, who was out front? It is actually the female astronomer who did a lot of it, and I think that is so fucking important.
Right, and it's just another example of representation matters. Whether you're
Representation.
whether you're women, LGBTQ plus,
Yeah,
you know, whatever.
You know,
it's
I can't tell you how many times it becomes so important, whether it is in a comment on YouTube or a comment someplace else, where it says representation matters, because it really is true. In the 80s and the 90s, it was, how were gay people portrayed? They had AIDS.
miscreants.
The miscreants. They had AIDS. This was the
Degenerates.
source of AIDS.
Yeah.
Was all these gay people, but you never saw them.
Because they chose to get AIDS.
Exactly. It is a choice. It is a choice to fuck some guy and get AIDS and, you know, HIV, which eventually becomes AIDS. But there was no representation of bi characters in like films or on TV. There was no representation of gay or lesbian. Oh, we won't even start with trans.
It took me until I was in my late 20s, early 30s to realize why I had such an affinity for She-Ra, Buffy the Vampire Slayer, and Xena Warrior the Princess. It took me until my late 20s when I was like, because they're women. Because they're women with power that were making a difference. And I was like,
they were
holy
strong
shit.
women.
That's why I identified with them. I didn't realize...
They were strong
I didn't realize in my
women.
youth, because they were strong women, it took me until I was older and had more of a worldview and evolved perspective that I was like, oh yeah, no shit, I was into She-Ra and Xena and Buffy because they're strong, powerful fucking women kicking ass in this world. Duh.
Yeah.
Like, I didn't realize that before.
And for me, there was no representation. Absolutely none.
Right, no bi
characters.
characters.
There was no representation at all. And not only that, you're told that, hey, you just happen to say, hey, I like the color purple. It became such a thing where, oh, that's a gay color. And then you ask the person, like, do you like the color blue? Oh, yeah. Well, then you're a fucking lesbian. It makes no sense. This whole color thing makes no sense to me whatsoever.
Why is blue a lesbian color?
Because blue, in like, at this time, is associated with boys. 100 years ago, pink was associated with boys. But whatever.
Up until probably fairly, maybe it was the early 1900s, boys were dressed in dresses.
Yeah.
Until they reached a certain age.
But there was nobody that represented me. And when I was in high school, there was nobody that represented me. And when you did see somebody that represented me, it was somebody that was a deviant or was just fucking weird,
Yeah, and for me, get back in the kitchen.
Yeah. And so, I was excited when, for the graduating class after me at Clemson University, there were 2 girls. 2 girls.
Women.
Oh, yeah. I'm sorry. 2 women. 2 women. Yeah. True. It was 2 women. And they actually, the really cool thing was they had gone to the Indiana University Cyclotron facility.
You went to that, yeah.
They knew me.
They knew you?
They knew me because of the picture.
Oh.
Because we took a picture.
Oh, okay. You had like a group photo.
Yeah, and they knew me. I was wearing a Clemson shirt, and they talked to me about it later on.
That's cool.
So, yeah. I mean, I have hope for humanity. I have hope.
Look, if we just get past all of our trivial bullshit, I mean, if we work together as a world species rather than just all this fucking states and countries and ethnicities and races bullshit, it's like, look, we're flesh and bone at the end of the day, and we have these higher evolutionary brains. Like, we could make a society in our world
separates us
and learn about a universe so much better than what we're doing right now.
There's far less that separates us than we think.
But you know what? I want 10 yachts.
10 yachts?
I want 10 yachts.
Like the boats?
Like the boats. I want 10 yachts, and that's what matters, is if I can get my 10 motherfucking yachts. That's all that matters, is that money.
Yeah, so, I think there's not a lot that separates us, but in our brains, there's so much that separates us, and it's so stupid. Like, for me and my dad,
we've evolved. Maybe our brains have evolved too much that we're getting in our own ways.
We're getting in our own way.
We need to de-evolve a little bit and go back to where we're together as cavemen and women,
I gotta be honest, and I will not survive to see this. I will not survive to see this. I cannot wait to when somebody goes, I'm gay, and then somebody goes, I don't give a shit. Where are we going to go get pizza? That, I cannot wait for that day to when
This hangover has taken a turn. Look what we've done in this hangover.
Right, I can't wait for the day. You gotta say something.
We're gonna have pizza later, and we've earned this pizza that we're gonna have.
Yeah, right. So I cannot wait for the day, and it won't be in my life where it doesn't matter who people love. That they're just who they are. That they are.
Who cares what bathroom you're going to use? You gotta poop, you gotta poop. No one's caring. No one's going. And no one gives a shit about when you're pooping.
Right. And so, I hold out for the day in which that people are, where really, truly the response is, hey, I'm a guy. I like that guy over there. Or I'm a woman. I like that woman over there. Or whatever.
Or I'm a man, but I was born a woman, but I'm a man.
Yeah.
And I like to do things.
And people literally go, what do you want for dinner? Which is, to me, I don't give a fuck.
And then the conversation goes, I don't know, what do you want?
Which is literally, to me, for
Chinese? Me. No. Well, you said you didn't care. And then it just becomes an argument over dinner. Which
for me is, we have come to a point where it doesn't matter.
No.
And
well, we need replicators. For one, because money's the problem in all of this. It's really all, at the end of the day, it's all about. Yeah. I'm a people.
And so, okay.
I mean, I don't know. I'd rather be Jack, Jack the dog, because he's just laying in the cat bed right now and is living his best life without a care in the world, other than when he needs to be let out to go potty or not.
So one of my favorite bands is NoFX, which is a punk band.
Oh, NoFX. If you just say that, it's no fucks.
No Fox, but it also was originally we're not going to put any effects on our guitars.
Oh, okay. I thought I just figured out.
But
I thought I just figured out a deep meaning to no effects.
Yeah, no, it's the FX, which is effects. But no Fox.
Jack is a bear. Jack, I don't know. We haven't heard from Jack. I don't know if he's still with us, but.
But there was a song that they have called. Is called Fuck Euphemism. Fuck Euphemism. Fuck you, Euphemism.
Fuck you, Euphemism.
Yeah, and so it's basically about a song about like how Fat Mike, who's the lead singer of NoFX, went to a bar and got into this quote unquote bar fight with a pronoun bar fight over. Pronouns with somebody at the bar.
It's a different word. Get over it. I know it goes against English grammar. Just say they. Yeah. Or say she. It doesn't. It's a word.
And so the guy that Fat Mike was arguing with was like, you're a rock star. You're being queer to basically drive record sales, and and Fat Mike was like. My gender is not fluid, but that's how I like my beer is the line from the song. But it was also basically...
Solid beer would be hard to get down.
Yeah, and so...
Plasma beer, oof, that burns.
Yeah, and so he's like, basically just call me person, short for person, for the night. And so, we're all people. Mm-hmm. We're not male, not female. I mean, we are, but we're not. And so, why are you yawning?
Reproductive purposes. That's all it is. It's just biology. You need it's this. That's all. It's like plugs. You need the male and female plugs.
Yeah. Who I am.
Babies that this
really and truly does not boil down to being bi or straight or whatever. It is.
Who cares?
Who fucking cares?
Why does it matter? Who gives a shit?
I mean,
you got stars. Look at stars. You got red giants. You got blue giants. You got I don't know.
I heard boob giants.
Blue giants. You got magnetars. You got neutrons. You got, what's our sun? Just a regular star. You got black holes. You got theoretical white holes. We'll see if that comes
that's not gonna
to
happen.
fruition.
We don't have any.
You got quasars. You got, look at the universe and you got planets and you got dwarf planets and you got comets and
You're
you
really
got
trying to pull this back,
asteroids.
aren't you?
I'm trying to bring it back to space and reel it in. That's what I'm trying to do.
But this is what the Hangover's all about.
Yeah.
But I think
Everybody's typed boob into a calculator. If you were born before when they stop using calculators.
Oh God, I just the 2 bits of news.
Wait, I'm sorry. Jack had to step away from his computer to wrangle a cow that had escaped and was wandering. I'm sorry, Jack. Why haven't you told us you had cows? You have cows?
Okay, hold on. It's funny. Your mom is like quiet through this whole thing, and they're like, I missed the ranch life.
You had horses. You had 2 horses, Mom. Easy to contain. They couldn't go far. Although, I remember a horse ending up on our porch one day, but that's because the gate was left open.
I gotta hear this story.
I don't remember what horse it was that was on our porch, but
all right,
or on our deck.
It would be great if Jack could let us know about these cows.
You have cows, Jack?
But I don't think he has cows.
They're not his cows. They belong to a neighbor 2 miles away, and the
What?
cow ended up in your yard just wandering around, and you had to go wrangle it. That's like our life living in Ogden, is we had to wrangle all the neighborhood dogs that got out.
Oh God, we were
dog wranglers, and every time
Rex.
we had
Rex,
the other people, their dogs. I don't remember their names. There was the lab that jumped over their fucking 6-foot fence.
No, but there was that dog that. Oh God, it was from. Oh, was it from? What's that? What is the Haunted Mansion ride in October?
Skeleton. Night Before Christmas.
Yeah, Night Before Christmas. What was it? The dog named from that?
Yeah, I don't remember. What's the dog's name in Night Before Christmas?
Starts with a U, right?
A U.
Oh, but anyway, we were always hunting down these
Zero!
dogs.
Zero's the dog's name.
Was it?
Yeah, it was
I thought it was you. It started with a U.
No, it was Zero.
Uba
Zero.
something.
No.
Okay.
No. No, Zero.
Anyway, we had to get that dog. There were so many dogs.
There's so many dogs. We're the dog rescuers.
We were.
Because we couldn't stand by. And one happened right before a podcast when Brandon was on his way over.
Oh, God.
That was...
That is true. Yes.
No, that happened twice. That was Rex. No. That was that Oogie Boogie.
Oogie Boogie.
Oogie Boogie.
Oogie Boogie.
And then there was that other dog that right before those people were going on vacation, and they had driven by.
That was Oogie Boogie, wasn't it?
No. That Oogie Boogie's owner came by our house. This was when we were walking down the street. Anyway.
Oh my God. Yeah.
So we know your plight, Jack. We've not with cows, but with dogs.
With dogs.
You're the cow whisperer, and we're the dog whisperers.
Wow,
anyway,
this is going crazy. Is that we have not talked about a single Magnetar in the Hangover.
We have not talked about a single Magnetar.
But we have talked about how, like, our understanding of the universe, as we get more data, changes. And there's nothing wrong with being confronted with things that we don't understand.
Yeah, there's nothing wrong with that. In fact, it's good for you. It's good for us as a species.
It expands you. It expands your horizons.
It allows us to grow as a species.
You know what? And to be honest, as people.
When we accept the unfamiliar, the uncomfortable, the misunderstood, because it really doesn't take anything from us to just accept something, to accept somebody, to just say, okay, what's it doing for you? How's it negatively influencing your day? To be like, all right.
Well, it's not. It's not.
You know, I mean, and to really look, I get on a scientific, the science stuff and the Big Bang and all that. I get how it makes people uncomfortable and how it fucks with their whole worldview of what they've been raised in, and you know what happens when they die. I mean, we as a species, we fear dying. We don't want to die. We don't want our loved ones to die. We fear being apart from people we love and what's familiar, you know. But I think that's just something that over time that we just have to deal with and accept. And there's a lot of us that, you know, are okay with that and are using our minds to be more open and accept things.
I mean, yeah, I get it's hard to do.
And Ron says, I got it on replay. As we get more data, changes. And he could not said it better himself. And on that point, I think it's a good time. Before we go any deeper into
I'm in charge of this episode, and Liz is trying to pull us in because we got pizza to get.
We do have pizza to get, although we have plenty of time for that. But, you know, we love all of you. And thank you for sticking with us and for watching us and for being here.
Yeah, I mean, the hangover, this is what the hangover is all about.
Right.
But we did talk about some things that were astronomy related. But, you know, in 2 weeks, join us for High in the Sky, where we'll talk about some things that you can actually see in the sky. We are going to point out to your mom tonight, podcast mom, where the Pleiades are.
Yeah, we got to go out early enough because last night it was too late. They were behind some trees.
We did have to wait until the moon.
Oh, Jack's a Ravenclaw. You know what? I'm not surprised you're a Ravenclaw, Jack. You seem like a Ravenclaw. I'm a Ravenclaw convert now. I was a Gryffindor according to the test I took on the Harry Potter website, or whatever it is. But
okay, so I think
Ron's Batman. I'm sorry, sir. I am Batman as well.
I'm Iron Man.
No, I'm Batman.
Iron Man's the best. Anyway, I'm sure that Katie could tell us more. But what is it with Ravenclaw? Because I think you and I really are actually maybe border.
Ravenclaw is more about like the smarts and the intelligent stuff.
But
no, Hufflepuff is loyalty. Oh, Gryffindor is like the bravery, and Slytherin is just being a sneaky ass fucking snake. Ron.
Okay, yeah. Just kidding. Ravenclaw is intelligent.
Yeah.
So I think you and I are on the borderline.
As long as math is involved, I'm okay.
I think you and I.
We're Griffin.
No, there you go. Hufflepuff isn't okay.
Oh, we're Griffin Claws.
Well, thanks
we're
for
Griffin Claws.
No, she said we're assholes because we don't have empathy. But anyway, we're assholes.
Hufflepuffs are sensitive, loyal, like they're just adorable, sweet things.
Yeah, but I think you and I are borderline.
We're
just in general, Ravenclaw and Gryffindors.
Gryffindors?
Gryffindors,
Ravendors.
We're Gryffindors.
I wanted to go Slytherin. So there isn't a video game I've played where I've gone the bad route, and I was like, "This is the game. I'm gonna go the bad route." And what did I do? I went the opposite of that. And every quest dialogue, I choose like the nicest fucking one.
Well, no. With the questions though,
Slytherin is ambition, yeah.
With Hogwarts Legacy is what we're talking about. So you actually did answer the questions for the sorting, just legit. You did.
I did, and then I chose.
But
Ravenclaw.
you did. But you then have the choice of choosing what you really want to do, and I just went with Gryffindor.
Yeah.
Gryffindor. But I could have been just as happy in Ravenclaw.
Yeah. Well, I also did Ravenclaw because I know you did Gryffindor, so I was like, well, this will be a good way to see a different story is progressive.
But then we went to the common room. Things.
Yeah, and then I was like, all right, but I'm a Ravenclaw convert. But
all right, I'm going to be honest.
Anyway.
If you do have a console to play video games, it's pricey. I get it, but
they're all pricey.
They are, but get Hogwarts
it's
Legacy.
Real fun. We've been enjoying
it. to be honest, it does start slow.
And Katie, let me know if you want Xbox One.
But Katie, please let us know because we got one for you. But it's actually a fun game. It's a very open world game. I'm looking forward to the Star Wars game that's gonna come out next month.
And if you just want to kill shit and be afraid for your life, just play Elden Ring.
Yeah. Oh my God, Elden Ring. So anyway, thanks for joining us. We'll see you in a couple weeks.
Is that how you're ending it? Just quick.
I can go further. I can go further with if you want to continue with us.
No. All right, we'll end this episode here. Anyway, thanks for joining us on the hangover of Cosmos with Cosmos. We've gone through the normal spectra of things from space things to political
and the spectrum with the rainbow,
humanity, and the spectrum of the rainbow. So we'll see you around next week. Bye. Live long and prosper.
And you know what? Stay true to yourself.
Yeah.
Be yourself. Cheers, everybody. Bye.
And now I'm going to get up and actually stop the stream because my mouse is way over there because it doesn't work that well
so
over here.
You can continue with us. All right. So you can please get...
And we're out!
Oh, damn it. Really?